Okay, people, welcome back. Welcome back. I'm glad to see you doing good on that because that finishes up that class. Um, I know there's a deadline on those assignments if you still want to work on them. If you're close to like a letter grade that you want, like within 2%, it might help you to do them. But in focus because that's the one that's going to go on your transcript. I'm not 100% sure if the O2 maybe it goes on your transcript, but just PA.
Mr. Cruz, you're breaking up on my end a lot.
That much I know. Mm-hmm.
You're breaking up a lot on my end, so I don't know.
You know?
Same.
Yeah.
Yeah, mine too.
Okay. Anybody else having that? Because I can maybe restart.
You sounding clearer now.
Some stuff, the session.
Yeah, I guess just wait and see. Because, yeah, you were a little bit clearer just then.
Okay, so I'm back on the audio, got rebooted. So is that better?
Yeah.
Okay, good. All right, so just remember, we're like in the last week of class. So you got, I noticed that a good number of people already taking it, but you got that test 4. It's due tomorrow, before class time. And then we got test 5 next Tuesday. The last day of regular class is just going to be review in both times, the morning and afternoon. Well, the morning session and the afternoon session. That's right, 11 and 12:30. And then the exam is. Wait a second. Let me check that date. I got Wednesday. That's not Wednesday. Let me check it. All right. I think Wednesday's the 17th. Let me just double check. This is all once we have the last day of class, which is I think Wednesday. Then after that, we go to exam schedule. Spring. So that's 25. Let's see if this is it. Summer. All right. So it's Thursday the 18th. That's it. Okay, that's what I thought. So that's the Wednesday is 1 week from today. That's the last day of regular class. So that's accurate now. So as I said for that, I'm going to open it up, the exam, for you to take it early during the regular class time if you'd like, but it's going to finish at 5:30. All right. So any questions about this with the calendar or anything?
So what you said, our exam, our final 120 exam will be open till 5:30?
Right. Because that's actually the time we're supposed to use.
Yeah, no, that's a good time.
But since we don't have to worry about rooms and stuff, the reason that they have that is because for regular classes, you got to make sure you know who's using the rooms. So after the last day of classes, they go to the exam schedule so that there's no conflict in rooms. But that's the last day. I mean, after that, again, the school is closed for the weekend. I'm going to get everything done that night, Thursday. Make sure everything's ready to go and grade wise. All right.
I had trouble with one of the questions.
What was it?
Can I send it to you in the chat?
Sure.
Thanks.
Okay. Probabilities cannot be negative and they can't be greater than 1 or 100. So that one right there should also be so neither of these three are valid probabilities. All the other ones would be. It's greater than 1.73. Okay. And that's a good question because students in the heat of the moment when you're working out problems, if you make one mistake and you got a probability, it comes out to 1.73. If you don't have in your head that a probability will never be greater than 1, you might not notice that. And a good example of that is that conditional probability problem that you had on the exam for the 020. If you reverse the numbers and you don't remember that the and goes on the top, then you could flip them and you end up with the large number in the numerator and the small in the denominator, which means you're going to have a probability greater than 1. So that's important to know. All right. Anybody got anything else? All right. So from here on out, we're just talking about the normal distribution and finding areas underneath this curve here. So everything under here is 100% or 1. Okay. So all of that under there. So what we're going to spend time doing is calculating how much curve there is underneath there based upon a certain value that we're going to get. And then we look at this thing called the Z-score, and then we look that up. So with a curve like this, what we call normal distribution, the mean, median, and the mode are the same. And we also know this. So if we know that no data is normally distributed, then we can use this thing called the empirical rule, because what this represents underneath here, this is your mean. And then each one of these hops from here to here is one standard deviation. No matter which way you're going, it's one standard deviation. The negative means it's below, the positive means it's above. Now, again, if we know it's normally distributed, then this area underneath here, and I'm just going to show you a little bit about what I'm talking about. This area, oh, I got on that crazy disappearing ink. So that area underneath there, imagine it's all shaded. So that part right there, it's outlined in red and that I've tried to shade in, is 68% of what's underneath that curve of the 100%. Now, if we go another standard deviation in either direction, 2, so in other words, we go over here 1 and back here 1. So then we're including now everything here. Imagine it's shaded. So including the red and now that blue, that's 95%. Okay. Now, one more. In other words, we're going out now to here. That little tail and this little tail. All three of those make up 99.7 right there. So that's this thing called the empirical rule. Some people call it the 68, 95, and 99.7 rule. And notice that there's a little bit left, like a 0.3%, less than 1%. That's what's out if you keep going. Because in theory, these things go on and on forever if you understand how math works. That line right there just keeps on going and getting closer and closer and never gets there. So there's a little bit underneath there. But with that, we can more or less judge how much data is underneath given those scenarios. 3 different ones. 1 standard deviation, 2 standard deviations, 3 standard deviations. All right. So you can also look at it sort of like this. This is another one that I got. Remember, this curve is symmetric. You got 50% on each side. So it also breaks in half. The 68 can break in half, 34 on the 2 little tails. That's half of that.
You're cutting out really bad.
All right, let me restart it. The only thing I'm going to do is restart everything, but let's see if this helps to restart the audio. Is that better? Well, if it gets worse again, I'm going to restart everything, but let's just see how far we can get. All right, so let's look at this right here. This is a little problem. So the distribution of SAT scores is scaled to be approximately bell-shaped, normally distributed, with a mean of 500 and a standard deviation of 100. Okay. So how many? Okay, well, let me rephrase that. So the question we're going to ask here is this first one. About 68% of the scores are between what? Well, we got to do a little bit of calculation to do that because we got to go one standard deviation on each side of the mean. So what that's going to mean is, and you can kind of go up here and see it, we're going to add one standard deviation to the mean and subtract one standard deviation from the mean. And the mean here is 500 and the standard deviation is 1. So we got two things. So we got 500 minus 100 and 500 plus 100. So the two score, I mean, the 68% is between 400 and 600. So in other words, if you were to go up back up here and kind of use this one as the standard here. So this right here would be the 500. And remember, the standard deviation was 100. So if we add 100 to that, there's your 600. And then if we subtract 100, we get 400. So that's how we got those values. Okay. Does that make sense?
Yeah.
So I think the next one is probably 95 or something. About 95% are between, well, the way it works is this is 2 standard deviation of the 95%. So now we got to add 100 twice or 200 and then also subtract 200. So right here, 2 standard deviations is 100 times 2, so 200. 500 minus 200 and 500 plus 200 gives us 700 and 300. And this little thing here is a neat little thing, tool. I mean, you really we can't use it within the context of testing and stuff, but let's just say, I'll show you this. So see, that would be the number between the 68%. And now if we go back out, it was 300 and 500. Oh, it wasn't 500. It was 600. Oh, it was 700. That's what it was, wasn't it? I forgot what it was. 500, yeah, 700. So there's your 95%. And then if you went out 3 standard deviations, then it would be between 200 and 800. It would be practically everything underneath the curve. Last question here. If you have a score above 700%, you're in the top what percent? Well, let's put that over here. I'll kind of graph this out for you on that little thing. All right. So how much is down there? Well, if you kind of go back over here and look at this kind of explains it. It's everything but this chunk right there, because that 700 was the line for the 3 standard deviations only on the right hand side. So you're in the top 2%, or you what we call in the 90. Let me calculate it out real quick. 100 minus 2.35. So you're in the 90, almost the 98th percentile, 97.65 percentile. But you're in the top 2.35%. So this is what this empirical rule can do for us. We can find some things real quickly by just using whole number standard deviations, but not all of these are going to be whole number ones, because you can have plenty of things in between here. And if we put something like, 523 here, see, then this is not on one of the full standard deviations, so it would be partial of one. Well, we got a way to figure that out. And then we go to a table and look things up. So when we're looking up things on this table, we need things called a z-score. In these first 3 problems here, there's 3 different scenarios. There's a less than. You can also say to the left or below, less than, to the left and below. And what that represents is if we have the z-score right here, they've given us that z-score of 1.18, and that's what that line is. So everything over here is below or less than or to the left of 1.18. Now, I was in those things and they give you a table in there. I don't know if I can bring it up right now, but I'm going to just find a table. Let me see if I can find their table. So that way we're using the exact same one, because sometimes they're different. So see, this is what they give you, because this is what somebody's taking off the screen. So they'll give you one that more or less encompasses what you need. This thing is rather big. So what I want to do is I want to look up this 1.18. All right, that's the z-score. And if you have a z-score, you go to a table. Let me find one that's full here so I can do it manually. Because that's not the whole one. So I want to get one that's the whole one. All right. Okay, so 1.18 so 1.1. So what we look at is we look on the column and find the whole number and then the tenths, and then we complete out going out here. And see, there's the 0.08. So then this right here is 0.8810. Well, what does that mean? Well, that means that about 88% is to the left of that line Z.18. More accurately, it was how much? It's 0.8810, so it's a little bit more than 88%. So 88.1%. Okay. Now that table always tells us what to the is to the left. And that's called the normal distribution table. Okay. So if we're trying to find out how much is to the left, less than, fewer than, then we get the z-score and we just look up in the table. All right. Now, the next scenario is above, to the right, greater than. Several different ways of doing it. So what that's talking about now is this. So that's this little chunk here. Let me get a different color. That's this part. Well, the table doesn't tell us how much is to the right, but we can use the complement rule. Complement rule. That's why we brought it up, because it's a very valuable tool. So if we want to find out what's to the right, we take that same value that we calculated for the Z.188, and there it is. Or not that we calculated, but we looked up. And then we're going to subtract from 1. And that tells us how much is over here. So all of that, the reason why they call it the standard deviation, because it's going to fit on this scale. And we'll see in the next little scenario, you're going to have to calculate, not in this scenario, but applications, we're going to have to calculate the z-score, which is not too hard at all. Don't worry about it. So above 1.18. Okay. Below, above, below. So that they're complements of one another. The above and below are complements of one another. So the table only tells us what's to the left or what's fewer than. So then we have to look it up. And you can also see how this changes depending on whether it's above or below. See, when we subtract 0.881 from 1, we get 0.119 or 11.9%, almost 12%. All right, one more situation. Let's say we have a between. Okay. So now we got two z-scores. Two z-scores. Well, how can we know what between is? Very simple. We're going to use subtraction. If you've got a friend and friend's one age and you're the other age, the way you find out how much older you are than them or how much older they are than you is you subtract the smaller age from the larger age. That's how we find these distances. You know, we got a nice numbering system because everything is centered at 0 where we start, and you go in the negative direction counting, and then you go in the positive direction. But if you want to find out how much is between two values that does not start at 0, or in this case, like straddle 0, then we got to subtract. Okay. So we got to look up two z-scores. So we want to know how much is between, how much area, that blue area is between negative 1.25 and positive 0.92, not quite 1. So watch this. I'm going to go back over to that table again. Let's see, and it was, this is the positive one. So let's get the that one out of the way first. What was it? It was 0.92. Because there's also a negative table. So 0.92, and you see that's that right there, 0.822. And then when we get the negative 1.5. Yeah. Was this? Yeah, and the negative ones now. So it was negative 1.25. So that is right here, negative 1.2. It's right on the bottom, actually. I can't read it up anymore. So 0.1056, a little bit more than 10%. Well, what we're going to do is we're going to subtract this amount from that larger amount. So the 0.8212 minus 0.1056 would be 7156. Let me go over here and show you this little graph a little bit better, and you can see the area. So it's between negative 1.25 all right, see that? This is all standard. That's why no matter what kind of calculator you use, I don't think your no, it doesn't. The TI that you use does not calculate these areas, so you got to use the table they give you in the Newton, and it's pretty much just like these, negative and positive. They might, the visuals might be a little bit different, but and they don't give you the whole table. They'll give you a section of it where the answer you need is located, and you got to find the one that's located in there. So see that? So about 71.56% is between the two values. We subtract the smaller from the larger. Because essentially what you're doing is you're just lopping this little chunk of it off. When you subtract, you're taking that little chunk off of the total amount up to 0.92. All right, now how can we apply this? Well, we got to have the z-score, and the z-score isn't always given to us, so we may have to calculate it, particularly for an application. All right. So here's how we calculate a z-score. It's got to be done in this order up in that numerator. You take the value that you wish to calculate for minus the mean divided by the standard deviation. Okay, so the difference between these two, and you always subtract the mean from whatever value you want, and then divide by the standard deviation, and then that puts you on the same scale, so you can use this or a calculator, anything. Okay, DGP University conducts placement examinations to all incoming freshmen. The examination scores of the 1,000 examinees last semester were approximately normally distributed, so that means we can use that table, with a mean score of 80 and a standard deviation of 5. What is the probability that the randomly chosen student got a score below 70? We'll do that one first. So that just says Z is 70, so I know which one it is. Minus the mean. And then divide by the standard deviation. Mean, standard deviation. Now this one's going to come out even. They won't always do this, because if they come out even, you can use the empirical rule usually, but so we want to find the probability that Z now is less than negative 0.2, and that's standing in for the 70. It's just standardizing it so that the table works. All right, so for the below negative 2.0, this was negative one. So 0.0228. Okay, so that's the answer for this one. If you need it in percent, of course, you multiply by 100. So that would be 2.28%. But probability is technically, between 0 and 1. You only write it in percent if you're asked to. Above 82. Well, let's go ahead and calculate the z-score for 82. And you generally need to have it in a decimal to look it up. All right, so 0.4. Now we got to remember this is above, so we got to take the complement once we find this value. So to just put it like this, the probability of X is greater than greater than 82 is equal to the probability that Z is greater than 0.4. One minus, okay? There we go. So we're just going to take, and we're going to find what the 0.4 is. So 0.4, 0.6554. So then this is going to be, well, we'll just hit it with a calculator and see. I can't do that with my head. So then that would be 0.334. So see, then this one is the 0.3346. And this right here is just, like I said, I'm going to take you through this to see it was 500. Oh, it was 80 and 5. Because this is calculating the Z-score for you. So it was below 72. So that's that little part right there. That's the 0.02. Hold on a second. Oh, it was 70. See that? That's that same value right there. It was above, was it 82? I think that's what it was. Above 82. And see, that's the 34.46 above. Now, the between is the most difficult one because you got to look up two Z-scores, or you got to calculate two Z-scores and then look up two Z-scores. All right. So between. So we got to do two Z-scores now. Let's do those over here. This would be the 75. And then the 90. So this is going to be 10 over 5. This is going to be 2. And then this one is 75. So there's our two Z-scores. We got to have those. And 90 and 75. Okay, so now that's what we got to find. Well, the way we're going to do it, we're just going to look up both of them, subtract the smaller from the larger. So let's see, it's 2.0, that's 0.9772. So that's 0.9772 minus, and then we'll like find out what this 75 is. I'm sorry, the -1 is. So -1, which they don't have on here. I'm just going to do it over here. I can even Google it. It was -1. Wasn't it? Yeah, I wanted to use the one that they got, but like I said, the way they do it, it's they only give you, like, for example, this one we're looking at -1. So they don't like maybe only give you half of this table. And if it were a positive one, they would give you half of the other table. So -1 is what it was, wasn't it? Yeah, -1. What happened to the one I just had? I got too much stuff open. This was the one I was just in. Oh, there it is. It was up the top. So 15.87. All right, so let's hit the calculator and see what that is. So so that's going to be right here. We'll just put it here. So this is the 0.8185. Okay. So a little bit more than 81%. All right. Any questions about those? I mean, that's the three calculations you got to do: the below, the above, which is the complement, and then the between is when you got to subtract. And if it's an application, of course, you got to calculate the z-score manually. So I'm just going to use the remaining time to just hit little things, because I went through the material in the Newton, and I'm going to go over the things, because it's not some of the things they go over. I said we don't traditionally go over with the textbook that we use, but I've got them in my notes because at one time we have covered them, and it changes depending on the book. All right, so distribution of data, there's different shapes. This is the one that we've been talking about here, is the symmetric one. And there, you don't have to do anything with the ones that are not symmetric, because they're not going to give you anything like that, because it's really it's beyond the scope of this class. It's also beyond the scope of the next class. So what they want to do is they just want to make sure you understand the concept of skewness and modes when we're talking about the graphs. So this right here is what we call positively skewed. And people mix this up, and I'm sure I did too when I first started this, before I come out with a way to help me remember it. Most of the values are on the lesser side, the negative side. So it's skewed to the right or to the positive side because there's a bunch of values over there. I'm sorry, or there's a few values over there that are causing the mean to pull up to the positive side. So that's why it's called positive skewed to the right, because those values way up there, they're outliers, they're extreme values. They pull the mean to the right or to the positive side. Okay, and it also affects the median. And then negatively skewed is where negative values, negative extreme values, pull the mean down to the left, to the negative side. Now notice in both cases, the mode stays the same, which is what's so interesting. That's why we need to have different types of measures of central tendency. The mean, median, and the mode are the ones that we primarily look at. They also mention the mid-range in the Newton, but that's like just add up the two endpoints and divide by 2. I showed you that yesterday about that midpoint. That's what it essentially is, mid-range, midpoint, same thing. So they're going to ask you about that. Also here, this is what they call bimodal data, and that's another one that they ask you about. If you have one hump like you have on one of these, you see there's one mode. All right. Now, when we say bimodal, we don't mean that there's necessarily two modes. We just mean that there's two humps in this thing. And matter of fact, this mode here would be the mode because there's a bunch of those here. You know, you can even see it's up here as 100. This right here tops out about 50, but this is what they call bimodal distribution, that it's got two humps to differentiate it from this, where you got one. That does not necessarily mean that in the data, if you were to calculate out what the mode is, that there's going to be two of them. There would only be one of them. But when we're talking about the graphs in comparison to the normal distribution, there's two modals points here and here. So that's another thing that they ask you about. They ask you about these three things. And I've taught these before. Like I said, we just don't really have them much in the book that we used with the Alex. That's what this one's got some other stuff that I like. Like this is good information. And a uniform distribution. Let's see. Let me find you a good thing about a uniform distribution. So they'll have some things in there that they draw. So the uniform distribution is just basically, and this is probably about the best example I've seen right here. Let's put that in my, steal it from these folks. Okay. It's not necessarily exact like a rectangle, but sometimes they do call it a rectangular distribution. But when you're using like this kind of a histogram, it's more or less just a big block. There's no gently go up and come down. It's definitely not skewed, and it does not have two humps in it, and it's not bimodal. So it's what they call in Newton a uniform distribution. All right, so they don't mess around with that J distribution. So let's go back up here. I'm just going to finish out the rest of the time that I got until I get tired of talking here about the mean, median, and the mode. I guess I'll just go back down here. All right, so if the mean, median, and the mode is the same, it's what we call uniform distribution. But if we have a high value in there, then it's going to cease to be in this category here, okay? It gets skewed to this side. So when we get that skewed, it's not so easy to find out the areas. But that doesn't matter. We're not worried about finding the areas. We just want to be able to identify them. So that extreme value, if it's a high extreme value, it pulls it to the positive side. If it's a low value, it pulls it to the negative side. So just in helping you remember this, the place where the high values are at is where it gets skewed to. So a very high positive value causes it to be positively skewed. A very low negative value causes it to be negatively skewed. Yesterday, I talked about that example with the grades that everybody knows about. If you got three B scores, 85, 86, and 82, and then you throw in one low grade, like a 30, well, bam, goodbye B, hello C kind of thing, right? And then if you have 85 average, same kind of thing with your three B scores, and you score very nearly 100, bam, it positively skews it. Hello A. So those are the concepts you're going to be dealing with in there. And I just would say I tried to take some of the ones out. They put this together for me from their textbook. And like I said, I'm taking stuff out, and I didn't have a chance to look at it because they didn't give it to me till the first day of class. But I'll just show you, because I sent you out an announcement about this. Let me do it as a student. Well, no, I'll show you down here. These three, these ones up here. Yeah, here it is. These are the ones that are in the Newton that I cannot. That's not it. Oh yeah, the ungraded assignments. There it is. See, those I took out. So you may see them in there. See, and I tried to put the date, and it still didn't change it over here. So I just make it easy. I just put it in ungraded. So I sent you an announcement about these, that you can leave these out. So the other ones that are there, because there was a bunch of them. I tell you, there was about 9 of them. So I took out 4, and I think there's 5 now, 5 or 6. So because I can't take them out because I changed them in Newton. It doesn't change them over here. So
Okay, I counted
that's part
6
of the
of them.
problem. Yeah, that sounds about right. So I took out 1, 2, 3 of them. That makes sense. 3 of them. Oh, 4. 1, 2, 3. So there must have been 10 of them. Let me go ahead and now see as a student what you see. And even the ones that are left, I mean, they're not perfect. But see, they're still putting them in there. Now that's the one, yeah. Now those are the, I forgot which ones they were now. All I can do is go to the announcement and look. My memory is not that good. So the frequency tables. So they still got it in there. I think it's going to be in here, but oh, these are the past ones. So this one you want to do, okay? It's frequency tables and histograms because we don't need that much detail on just frequency tables. So that's why that one is there. So if there's one in there that says frequency tables, this one, like I said, I changed the date on it, but I may see if I can change them over here, but they are in the ungraded after we finish here. I didn't think about just doing it over here. I think if I change them here, that might do the trick. The other one was Measures of Central Tendency Part 2. Weighted averages. And then skewness and standard deviation. So I'll tell you what, I'm going to do that right now. Well, anyway, that's pretty much it. So tomorrow,